Okay, hi guys. Today we're going to look at making a confidence interval for a mean. Okay, so just a reminder from what we've done before, these are our formulas. So this is what we use when we have n and p hat. Okay, and these are the formulas from your quiz when you have x bar, a mean, a standard deviation, and a sample size. So we use these ones when we had those values. So the question in your launch today, a questionnaire of spending habits was given to a random sample. We know we like random samples of college students. Each student was asked to record and report the amount of money they spent on textbooks in a semester. In the sample of 130, so that's our sample size, resulted in an average of, so since that's in the sample, that average is x bar is 422 with a standard deviation of $57. Create and interpret a 90% confidence interval. So you're used to looking at that and doing these steps of panic for the mean. So you should be saying to yourself right now, we haven't done this for the mean yet. We've only done this for p hat. You do know how to work with means though, so we're going to get started on trying to do as much as we can with this. So the first step of panic is, what's our point? Well, we wish to estimate the mean amount, not the proportion, the mean amount, I'm abbreviating, spent on textbooks. Okay, so checking our conditions is what comes next. I call that assumptions and conditions. The first one is randomness. We were told a random sample was taken, and this was of college students. So we'll add that context. So we need to make sure we have a good sample. We need to check independence. So our next one, we're going to say something like n equals 130 students is less than 10% of all college students. So assume independence. That means that how much someone pays doesn't affect how much somebody else pays for textbooks. Okay, the third one here, we used to do n times p or n times p hat if we didn't know it, but we don't have a p here, so we can't do this. So what we did when we had means or averages was we checked what was nearly normal. Either we were told the sample was nearly normal or our sample size was big enough. In this case, we have 130 students is greater than 30. That was our check. So the cost of books is nearly normal or approximately normal. So this was what you had done on your quiz before checking these three conditions. So the next step of panic is to name the interval that we're going to do. So far, all you know is a 1 proportion z interval. Obviously, this is not a proportion, so we need to learn a little bit before we can create this new type of interval. So if you look at the bottom of your page, we will come back to this. Remember from our last unit and from your quiz that the central limit theorem, sometimes abbreviated CLT, states that for large samples, no matter what you're coming from, that the sampling distribution will be close to the normal or approximately normal. And there are two ways to check this: was if n was greater than or equal to 30, or you were told the data was nearly normal. So what we're in is a situation where we have means. So remember the symbol for proportions. We had p hat to estimate p. So what we're going to do now with means is we're going to use x bar to estimate mu. And what this means is that we need to use the sample mean that's given in a problem to estimate the population mean. Going back to our formulas for means, we know the mean of x bar is mu, and the standard deviation of x bar is sigma over the square root of n. So we're in this situation now where we don't know this number. We also don't know this number. All we do know is s. So we're going to have to use s to estimate sigma. So there's a lot of estimation going on in here. So since we're going to have to use S instead of sigma and X bar instead of mean, we have to add for some extra variation, because in proportions we only had to use one number to estimate one number. Now we have two different values we're trying to estimate. So this new distribution is what we call a T, no longer a Z for the normal. So some notes on this before we go on is that this T distribution is a whole family of distribution that is defined by what we call degrees of freedom. We often abbreviate degrees of freedom as DF. Okay, it has one parameter, this T distribution. The one parameter is what we call degrees of freedom, or DF. The normal distribution, if you remember, had two parameters, the mean, and you can fill in your blanks now, and the standard deviation, mean and standard deviation. Okay. On your formula page, so it's going to be very similar to what we've done so far. On your formula page, you have a table, and on that table is, if you see here, this T star. This looks just like the normal distribution. Looks very similar to the normal. But it's not. It's actually what we call the T distribution. It's very, very close to the normal, okay? And it depends on each of these degrees of freedom, okay? Part of this table is also where we had our confidence levels here that we used for the Z. Okay, so this is on your formula page, and what I want you to see here is that this T distribution really has the same shape as the normal distribution, so it works very, very much the same. Okay, and what we want to do now is use this T distribution almost like the normal distribution. So just below this on your notes is how to make an interval, a confidence interval, so a range of numbers for one sample mean. So define your parameter. We wish to estimate the mean. Check your assumptions, random, independence, and now this is nearly normal. The easiest way are that you're told, or your sample's bigger than 30. Since conditions check, we can create a, and now this has a new name. Before it was a one sample, a Z. Now it's a one sample T interval for means. Before it was for proportions. And now we have to list our degrees of freedom, and our degrees of freedom are sample size -1. Get your interval from the calculator. On the calculator, it's called T interval. You know that we don't do any of the math by hand. And then interpret it, talking about the mean using units. So this is what we're going to be doing in class tomorrow. And what we're going to be doing is actually completing the question from our launch. So the question from our launch, by the time you come in class tomorrow, you should have up to the end step, and that's where we're going to finish up. So again, we're not quite using the normal distribution. It will have that nearly normal shape, but what we're going to have to use is what we call the T distribution, because we don't know, the population mean is unknown and the population standard deviation is unknown, so we'll have to use what we call the T distribution, not the Z distribution, because we're estimating too many values here. Okay, thank you for watching this video for homework, and I'll see you guys in class tomorrow.